So when using the exponent law, you must have the same base. Okay? So what we see here, we see that a to the power 4 times a to the power 5. Your base is a, right? So what does it mean when I say a to the power 4?
A multiplied 4 times.
4 times.
A multiplied by itself 4 times. So it's a times a times a times a,
Same.
right? Now I'm also multiplying it by a to the power of 5. So that's another a times a times a times a times a, right? So altogether, how many a's multiplied together do I have? 9, right? So that's why I write it as a to the power of 9, right?
So we add the power.
Exactly.
We don't multiply them.
Exactly.
Okay.
So this is, you just came up with a rule. When you have two exponential terms that have the same base and they're multiplied together, you add the exponent. Okay? So let's try the next one. So a to the power of 2 times a to the power of 4. What do I have to write?
6, a power 6.
So I have to write a times a, right? That's for the first one. And then times a 4 times, right? So altogether I have a to the power of 6. How about here? What do I have?
No, 5.
What's the power here for this one?
Oh, 1.
1, a power 6.
So 6, right? But if I want to write it as expanded, I would write it right? Where I have 5 of them first and then multiplied by 8. So that will be a to the power of 6. Okay, so the rule is whenever you have a multiplication, right, you're multiplying, you're going to keep the like base. The base does not change. And this is where most people will make mistakes. Okay, so keep like base and add the exponent. So for example, if I have 5 to the power of 2 times 5 to the power of 4, what happens? What do I get?
6.
5 power 6.
5 to the power of 6. 6 by itself is not enough, right? It's 5 to the power of 6, right? You see how the base stays the same. The base doesn't change. You're not multiplying 5. You're not adding the 5. You're keeping the base the same. Okay? Are you guys okay with this? All right. Now, what happens when I'm dividing? That's right. So if you look at the first one, I have a to the power of 5 divided by a to the power of 4. So if I expand it, I have a times a times a times a times a divided by a times a times a times a. So what happens here is, if I simplify, one from the top, one from the bottom, one from the top, one from the bottom, one from the top, one from the bottom, what I have left is a to the power of 1. So that's the same thing as saying it's a 5 take away 4, right? So the exponent of the top minus the exponent of the bottom. Okay? And the reason for that is because I'm simplifying, right? So what would your answer be for the second one? A to the power of 2, right? Because if I have 4 take away 2, that's going to be a to the power of 2. Do you guys understand why is that? Okay. How about for the next one? A to the power of 4, because if I do 5, take away 1, so that is a to the power of 4. How about the next one? A to the power of 4 again, because I have 6, take away 2. And the last one is A. Right? So the rule is you keep the base, and you subtract the exponent.
Confused me here. On the second page for a second, but now I get it.
Are you guys okay with this? Now we have the power of a power law. Okay? So what you see here is you see a to the power of 4 to the power of 5.
I guess here you have to multiply together.
You multiply the exponent. Because look what happens. I have a to the power of 4 5 times. Right? Because I have a to the power of 4 and then to the power of 5. So I have a to the power of 4 multiplied by itself 5 times. So a to the power of 4 times 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 a to the power of 4. So if I add all my exponents, 4 plus 4 plus 4 plus 4 plus 4, I get 20, which is the same thing as saying I have a 4 to the power of 4 times 5. Okay? So you're multiplying the exponent, the two exponents. So that's the same thing as saying I have a to the power of 2 times a to the power of 2 times a to the power of 2, which is a to the power of 6. This is the same thing as saying I have a to the power of 5 times a to the power of 5, which is a to the power of 10. You see that I keep the base the same, right? The base does not change. Okay, so the rule is you keep the base and you multiply the exponent. Are you guys okay with this? So let's look at, Sorry? You multiply this, right? 2 plus 3 is 5, not 6. For these ones, if you expand, then you add your exponent. But if you keep it like this, you multiply the exponent. That's simple. Okay, so what would be the answer for the first one?
X
3 plus 3.
Then 11. X power 11.
How about for the second one, 8? X squared to the power of 4.
X8.
X8, because what do?
Multiply.
Multiply the exponent. I have exponent to the exponent, so I have to multiply them. So I get x to the power of 8. How about the third one?
You simplify them. Which is X6.
X6. So 9 take away 3, so that is 6. So you have to realize, is it multiplication, is it addition, or sorry, is it, am I multiplying, am I adding, or am I subtracting?
That one was, the first A was multiplication, right?
A is,
Adding?
you're adding the exponent.
Okay. I just want to make sure.
Okay, how about for D?
Yes.
Adding the first bracket.
Adding X power 4 and Y power 6.
You add all
Seven.
the exponents
Seven.
together?
Not all of them together. Remember, you have to have the same base.
Oh,
Right?
okay.
So, because this right here, they have the same base, right? So this is where I add the exponents,
Wait, what?
right? You see the x?
Yeah, I see that.
Yeah.
But
So
when
you
you
add
put
the
it-
exponents
Okay.
for that. So that's going to be x to the power of 3 plus 1. Yes? Now,
Why 7?
the y, you add also the exponents for it. You have to have the same base. If you don't have the same base, you can't do anything. So your answer is going to be x to the power of 4, y to the power of 7. And that's it. You can't do anything else.
Oh. Isn't X, Y one? Like one thing, you know what I mean?
What do you mean?
Like X, Y is, see how X, like in the first bracket, X, Y, like X has a 3 power of 3, Y has a power of 2. Isn't the second bracket X, Y, like X, Y, doesn't that equal 5? Isn't
No,
that like
x
one
has
thing?
a power of 1.
Oh, okay.
Because it's like this. Right?
Yeah.
So that's a power of 1.
Okay. You'll probably have a question here. I'll show you what I meant by.
Okay. How about E?
X. Yeah. X to the power of 10 and Y to the power of 3.
And
X
Y
to the power of 10 and y to the power of 3. This is multiplication here. When you have multiplication, what do? You add the exponent.
Yeah.
Right? So it's x to the power of 10 and then y to the power of 3. Why does y not change?
Because we don't have the base.
We don't
the
have
same
y. We
base.
don't have the same base. Right? So y has to stay the same. X, you're multiplying. So that's the same thing as writing this. Right? That's the same thing as writing this. So what you have to do here, you have to add the exponents of the x. So 4 plus 6 is 10. And then the y stays the same because there's no other similar base to it. Do you guys understand that? Okay. How about the next one?
2x1, y3.
That's right. So 2, there's no other number, there's no other coefficient that I can simplify the 2 with, right? There's no number right here in front of the x6. So 2 is gonna stay the same. Now, when it comes to the x to the power of 7 divided by x to the power of 6. So I have to subtract the exponent, and that will become 7 minus 6, which is 1. Then the y, I have y to the power of 4 divided by y. So I subtract the exponent, that will be y to the power of 3.
3 power of 2 or 3?
4 minus 1.
4 minus 1 is 3.
Y to the power of